Alright, hello and welcome. This is a series of programming tutorials on the C programming language. We're going to start off with the most basic information, and the first thing you need to do in order to get up and running is to get a IDE. In my case, the IDE that I'm going to be using is called Cloud9. If you're a programmer already, you can sign in with your GitHub or your Bitbucket account, or you can sign up to create an account through them. In my case, I already have an account, so I'm going to go ahead and sign in. Now it's welcome me back. And here I can look at my different workspaces. Once you've gone through the little sign up thing and told it that you do not want to upgrade to premium, click on create new workspace. Click on the C++, and you can call this whatever you want. C program tuts or whatever. Since I already have a workspace called C tutorials, and if you want to look at it, you can go to this URL and it'll allow you to look at it, which is one of the things I like about Cloud9. Then you go ahead and fire it up. Anyway, in my case, I'm already actually logged into Cloud9, so I don't need to do anything special. Whenever you open it up and you create your new C file, by default you're going to get these hello world, makefiles, readme, markdown file, and a few other things. These are for GitHub. These ones just give you the basic overview of the syntax for these two different languages. I just put them into the default folder just to show you that when yours opens up it's going to look like that, but in my case this is the first video, and so I have a video 1 folder. Alright, so first things first, what we're talking about first is sort of before you get into programming. This is sort of how do you go about setting things up before you do that. It's called the software development method. And basically the way it works is that if you're given a problem statement, you need to analyze it and break down the problem such that you can come up with solutions, and you can test your solutions to make sure they actually do what you expect them to do. So for example, here's something you get in a lot of textbooks. Given a list of items stored in a file, sort them in alphabetical order, and then write them to another file. And as you can read here, you can actually go here and just read through this. But the problem is you have a ambiguous statement. A list of items. What sort of list? Is it text? Is it numeric? Does it have special characters? Is it an array? Is it an object? If you don't understand what those last two mean, don't worry. As we get further and further, we'll cover all that except objects, because C programming doesn't really have the concept of object-oriented programming. But it sort of has functions, which is its way of dealing with some of the benefits you get from object-oriented programming. But anyway, we don't know what's in this list, and we don't know what language it must be written in, and that's called a design constraint. And that's basically technical limitations, like the program must run. For example, if you do web-based programming, it's common conception that the perceived user time, which is how long the user perceives your application to fire up, should be less than 5 seconds. Now it's important to note that word perceived time, because when it comes to programming, the actual time it takes to do something and the perceived time, which is what the user sees, can be two very different things. That's an important design constraint. But anyway, design constraints are sort of that thing. How long should it take? What language must it be written in? Things like that. And then you have program restraints, which is the definition of what the program should do. So what do you actually want to have it in? That's what we see here, given a list of items stored in a file, blah blah blah. So your first step whenever you analyze a problem that you get in sort of a textbook or from anything is to specify the problem requirements. Come up with a clear list of statements. And jumping on down, that's what you see here. And this is the famous widget problem. If you've done any sort of programming books, you invariably run across the widget problem. But basically, it's given the amount of widgets purchased by a person, calculate the total cost of the widgets. So once you have your problem statement, your next thing that you're going to be doing is you're going to be designing an algorithm to solve it. And particularly as far as C goes, there's really only three things you're doing. You're getting inputs, you're displaying outputs, and you're performing some sort of computation formula or algorithm. And so in this case, when we look at our inputs, that's the number of widgets purchased and the cost per widget. Now, the first one is something from the user, and the second one is something that we handle. This is going to be a hard-coded value. And for the outputs, we want to display to the user, once they've input the number of widgets they want, what the total cost of those widgets will be. And then from that, my formula that I think is going to work for this is simply total cost equals cost per widget times widgets purchased. Now, before you start writing code, it is always a good idea to verify, to test the algorithm first. You can test it directly in C if you're good enough. The problem is that you might get confused. There are certain syntax-based problems and there are certain semantic-based problems. A syntax problem is where you just simply write the code in such a way that the program or the compiler that you're using doesn't understand what it is. The bigger problem is a semantic error. A semantic error is when your logic is wrong. You won't see an error. Nothing is going to display to you an error. But the end result of whatever program it is you run will not be correct because logically you have made a mistake. And that's one of the things you try to avoid, because while users tend to run into a lot of syntax problems, more advanced users tend to run into semantic problems where their logic just isn't quite working. And one of the big things that's come around has been the idea of test-driven development, or TDD. And that sort of emphasizes writing tests even before you start trying to write the code, is to make sure that your logic is sound first before you even worry about the syntax of the code. Anyway, once you do that, you break down your task into smaller subtasks until you come up with something that's manageable. And in the case of the widget problem, there's not that much you need to do. You get the number of widgets, you compute the cost times the amount they purchased, and then you display that results back. The next step in the process is you actually have to implement the algorithm, or just write the code basically. And then once you have written the code, you actually test your code. Does it do what you expect it to do? And particularly, one of the problems that you will get is this one. People frequently do things you do not want them to do. In the case of, if you switch to web programming, you have to handle both malicious problems, which is where someone is deliberately trying to break the system, and then non-malicious users, people who are just not paying very much attention. And you figure out how you want the program to handle it, and how do you deal with all sorts of different data types, or if someone puts in a 0 and tries to divide by it, things like that. And the last piece is you have to update your code. And that gets into best practices to write clean code and maintainable code. And one of the principles in the Zen of Python that I like is that code is written once but read 100 times. That means basically you're going to, not just other people, but you yourself may have to go back to code you've written before and read through it again to figure out what it's doing. And if you're not writing clean code, this can be a maintenance nightmare, and it'll cost you a ton of time to run back through your code and figure out what everything is doing. For beginners, it's best pretty much to comment everything, just assume that everything needs a comment. But when you get more advanced, you're going to be able to tell what something is doing by naming variables correctly, by managing scope, by using refactoring methods, which is a fancy way of saying making the code easier to read and run, stuff like that, which in later tutorials we may get around to that. Alright, so once you have your Cloud9 open, the first C program that you write, and this comes from K&R, which is I think, what's their names? Kernighan and Richard, and Ritchie, excuse me. They wrote a very famous book called The C Programming Language, and in it they wrote the Helloworld Function, and since then that has become the standard for the first thing you write in programming. So this is the Helloworld Function. The first line of code in here is the include stdio.h. That means include standard input output header. And what does this do? This specifies that this defines the printf, scanf, and other useful input and output operations. Now notice that the code changes. This is called syntax highlighting, and that basically means that depending upon what you're doing, the way things are displayed will change. And this is very useful to programming because, for example, if I left this off, I would immediately see everything turn blue and italicized, and that would let me know that it did not close out the comment. Comments do not do anything really. They basically display once it's compiled as one blank space. So that's a blank space in between here and here. That's what they actually compile to. So they can be as long as you want. The only thing it'll add is one extra blank space. When you're starting off again, you should use them liberally. This is the first way of writing comments. And this method is known as the multi-line comment method. This is what C actually supports by default. So to see why it's called the multi-line comment, I can put more comments, more comments, more, so forth and so on. Traditionally, it looks usually like this. Usually people tend to line these up and put a series of asterisks so that way you can see where it begins and ends. Now, I find that this practice is not necessary with syntactic highlighting editors. So this sort of, in fact, usually it's something more like this, is what you'll typically see if you run through people's code. So something like that. With syntactic highlighting, that's really not necessary, but that evolved because back in the oldest days, it needs to reconnect my terminal. So hold on, there it is. Let's say I want to touch a file, and this is just called test.c. Touch is a special command in Unix that just creates a file and then modifies it. So if I keep touching it, it'll keep changing the modified date. So anyway, once I do that, the oldest text editor that I know of at least is called Nano. It was originally called Pico, Nano being 1,000 times greater. This is the improved version, but it looks like this. And include H, and in here you can clearly see why it can be difficult to see where a comment ends. Where does it end? Well, of course it ends at this part, but without the syntactic highlighting it is pretty difficult to know where a comment begins and ends. So because of that, that sort of convention arose where everything was lined up and it used asterisks at the beginning to specify that everything that follows is embedded in a comment. And looking at this, it's much easier to see now what's in a comment just by rolling on down. So that's where it came from. If you are using Nano, Control X will exit out of there, which you can see if I hit Control C. Any of these things on a Windows machine at least is the Control key. I'm not sure for you Mac users. But if you are a Mac user, you have the advantage that the Unix system is what Apple runs on, so all of this stuff you could actually pop open your terminal prompt and run it and it would work just great. So if I hit Control O, that gives me the output, and I can write the test.c, which isn't going to do anything, so I really wanted to make a C program. I'll start off with int main. So this part gives me access to the printf and scanf function, which is something you'll be using a lot. The next piece is int main. Main is a reserved keyword. This tells C where to begin executing the program at. The include statement is what's known as a preprocessor directive, and all that it does is it literally grabs the contents of the standard input-output header file and it pretty much just pastes it right in place. In this case, these opening angle bracket and closing angle bracket, or you can think of it as the less than and greater than symbol. Those two pieces mean that this is a standard library. Standard libraries are just libraries that the committees that form the C committees have decided are so useful that they just make them libraries you can tap into anytime you want. So that way you have certain defined functions without having to write your own scanf function that gets user input, or write your own printf function that prints out to the user what it is you're doing. So here we have printf and hello from Nano. So what is this symbol here? One of the problems or advantages or disadvantages, depending how you want to look at it, of C is that it's what's known as a white space insensitive language. So I'm going to go ahead and just write this out. Then I'm going to pop on down Oops, I don't want to open up Windows. I'm going to pop on down to the mini terminal. I'm going to type in cd dot dot. The reason why is cd means change directory. And to become a very proficient programmer, you have to learn a lot of commands and how to really work the terminal. So if you've never used the terminal before, this can seem like magic. Like whenever I demo this in class, some students are like, they say, I feel like I'm in the Matrix, or I feel like I'm a hacker. No, you're not. These are very simple commands that just do very simple functions. Anyway, change directory dot dot means go up one level. And so if we do that, from where I am on your individual computer, this won't work because you're going to have a totally different path than I will. But it brings me back to my home folder, which is where my test.c file resides. So what do I do once I have this test file out? Well, I created this little file here, and it sort of lists what happens whenever you execute a program in C. And so the first thing you have to do is you have to actually write the code. And you must use a text editor. And whatever you type in here, the compiler will attempt to translate that into machine code. And for our purposes, I'm using c9.io. You don't have to. There are tons of compilers out there and tons of text editors out there. But in this case, I like it because it's free, it's online. You can look at my source code, you can host files, you can use Markdown. There's all sorts of like really cool stuff that you can do in Cloud9. So for me, it's the winner. Once you get your text editor and you write all your stuff, you're going to be doing this as plain text, and that's really important. For example, if you're on a Mac, by default, I think the default text editor that comes with it, it tries to save files as rich text format. Problem is, rich text format, RTF, comes with formatting and all sorts of other little macros that it defines that tells any rich text anything that understands rich text, how to format the document margins and padding and 1 inch from the left, 1 inch from the right, etc. But if you try compiling that in C, it's not going to understand it and you're just going to get an error. So it's very important that this is just plain text. And that's one of the other key things. There's really nothing miraculous about writing code. It is just plain, ordinary, average text. The text editor doesn't matter at all, which is what I was demoing with Nano here, is that this is the simplest text editor in the world. So it's not Cloud9, and it's not if you're on Windows, Visual C++, and if you're on the Mac, it's not Xcode. It's just text. Nothing fancy or special about it. Anyway, you must make it a plain text because it says here it'll add in the other formats, Word, rich text, etc., add in their own code that messes with the C compiler. Once you do that, you must compile the code, and that's where the compiler will attempt to translate what you wrote into machine code. And to demo that, the command, at least in C9 or any Unix-based machine, is G++. Now I'm actually using the C++ compiler because I think it's a little better than the standard C compiler. But whether you use the C++ compiler or the the C compiler, which is GCC, they both work just fine. But the G++ one I find to be a little bit better, so that's what I will be using. So I'm going to type in ls. This means list, and it basically means list the contents of the directory. And here I see I have in blue the default folder and the video1 folder, and then I see my test.c file. That's the one that I want. So what I'm going to do, I'm going to type in g++-c test.c. As soon as I hit return, it is going to compile that code and give me the object file, which is this .o right here. So at this stage in the process, one of two things is going to happen. One thing that can happen is that you will get an error message right here, and that's where the compiler will have an error, and the compiler will attempt to tell you what went wrong. It is very, 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 very important that you actually read the error message you get from the compiler. So let's say I do this. So what I've just done is I've removed the ending curly brace. These are called braces inside of C. Now because I only have one statement here, which is just hello world, this may not give me an error because braces are technically only necessary if you have more than one statement. Anything like this, that's called a statement. It's where you're basically saying, I want to utilize the print function and I want it to output hello world. That counts in both regular English and in programming languages as a statement. That would be a self-contained little bit of information. So printf, this Oh, I just got disconnected. Hold on. And I'm back. Alright, so I'll have to jump back in there, and then you can see they try to save it out. So, there we are, blah, 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 it disconnected me. So I'm going to printf another one, and this is going to say goodbye from nano / in. Well, actually, no. What does that? Okay. So now I'm going to output that, and then I'm going to try rerunning the G++. I'm going to try rerunning the G++ command. And right here it says error. Test.c, line 13, character 33, expected a closing curly brace at the end of input. Well, inside of nano, being what it is, it's not very easy to tell this, but let's open this up and see. Line 13, character 33, so right about here, it's saying I expected to see this. So it nailed it pretty much right on the head. It has exactly what the error was. So let me save that one out, run this again, and it compiled it just fine. I'm going to get rid of these two files because they're not necessary. S2all. It's not my test.o file. Alright. So from there, what happens? So we got the error message, it told us what the problem was, and we fixed it. If you really mess up, you're going to get a whole series of problems. It is almost always true that whatever the first problem that goes wrong, whatever the first thing it displays is, that's where your real problem is. The other errors are the result of that one thing not going correctly, and it just keeps running through and telling you all the rest of your errors. So what if it's successful? Right? So now we're successful. It's going to give us an object file, which is a binary format. And that's exactly what this is. This is a binary file. I'm not going to open it because it's just going to come out as garbage probably. Blah, if you can even read it. Sometimes if it does this, it hangs up on you. That's where it can't figure out what it is. Sometimes it's just because the Cloud9 service can sometimes be a little slow. Anyway, we'll let that run in the background. So from there, we have our next thing we need to do. So we compiled it. Now we need to link it, and this resolves the cross references among the object files. Now in our case, we only have one object file really, and that's the one hello.c file, or what I call, no, test.c is what I called that one. So now we need to link it, but if we did have multiple C files, this would be where it starts bringing stuff in between them. So I'm going to go ahead and Control X, which will get me out of that. I'm going to type in clear. Clear is a Unix command that will get me back out to my terminal, so now I have two terminals open. Yeah, this just ain't happening. Okay. So now let's say that I want to actually create an executable file. So I'm going to use my G++ -o. I think of it as output, but it's probably actually write out. And then test.o. Oh yeah, actually, that's incorrect syntax. It's first you tell it what file it is that you want, then you do the -o, and then you specify what you actually want to name the file. Now you can either just write in test, which will behind the scenes make it an executable file, or you can actually specify deliberately test.exe, and that will actually convert it into an executable file. Let me refresh this, make sure that whenever it connects and disconnects, you can sometimes cause little weird errors, which seems to be what I'm going through right now. If Cloud9 really messes up on you, then the easiest thing to do to fix it is just to refresh your browser, and usually that fixes it. I was just checking because I still got these like temporary saved files. But anyway, I'll pop back open test.c. By the way, my default editor probably looks different than yours. Go to View, go down to Themes, and you can pick whatever theme you want. So there's it. Now I've got my beautiful syntax highlighting. Alas, I have my test.exe file, so when I jump back to the process, I now need to, I got my executable, I now need to load this file into memory and begin executing the instructions. And on a Unix machine where the environment path has not been set up, don't worry about it, but it's // and then whatever executable file it is. So // and then in our case it's text.exe. And now you see hello from Nano, goodbye from Mail, and what does the /n do? Well, if you're curious, the /n means new line character. So let me demonstrate a quirk of the C language. C is whitespace insensitive beyond one character space. That's the reason why the comments output as one space. Every return, if you do this, that's all one line of space to C. So you can write hideous looking code like this. Let's really mess this up. Now inside of here, this is an actual string. We're not going to get into strings just yet, but basically anything you put in between double quotes or single quotes, that is telling it that you want to display the results of whatever's in here. So in this case, because it's going to print out whatever I put inside of here, then except for that won't work. But because it's going to be displaying whatever I actually type in here, then if I do this, I will actually get space. But one of the downsides to, well, there's a couple of different downsides to this, but let me just rerun everything. You don't have to go through the whole compilation process. You can actually directly compile the C file itself. So you can do that, and that works just fine. /test.exe, and you say that the white space that is in between the quoted string, that is actually displayed to the end user, but everything else, it completely ignores the white space. So I'm going to Control Z. That will get you back up until the point where everything looked, more human readable. Okay. So now everything's back to being good and human readable. By the by, if you ever want to see what you've done, you have this file revision history. As you scrub through this, it'll actually show you, in my case I only have 3 saves, it'll actually show you what you did and when you did it. Very handy if you have to be an instructor like me and you want to know if students are cheating. It's pretty obvious to tell. When you're done with it, you can go to File and shut that down. Also, if you ever screw anything up really bad, it's nice to know you can step back in time even as you save it and that everything will still work. So, the /n means new line character. It's whitespace insensitive, so that means that if we put returns in between these statements, it will ignore it. The other quirk of it being whitespace insensitive is it must have a terminating statement, or terminating character, and that is this semicolon right here. That means stop what you're doing right here. Now there are other programming languages, in particular Python, which I've already mentioned, that is whitespace sensitive. The way you use whitespace inside of Python will actually change what the program does. C is not one of those languages. It is whitespace insensitive. So now I've changed my file again. I'm going to rerun it, and just to make this look a little better, I'm going to actually add the new line returns. Now it should be very, very obvious what it does whenever we compare the two different pieces of code. Rerun it, oops, recompile and link it, then rerun it. And what you can see here is that every time I have the new line character, it drops this down onto a new line. So, quick review. We have the include statement that grabs the contents of the standard input and output header. It just pastes it right in place. To do a comment C style, it's a multi-line comment, it's a / and an asterisk, and that tells it to ignore anything that follows until it hits another asterisk and a / and that tells it to end the statement. And this is a C++ style comment, but the C people liked it so much they added it. Typically you see this one in places like this, begin main function, So that rather, it's just a little simpler to type to do the 2 forward slashes. The downside to it though is that if I go to the next line, you can see that it's no longer in this quote. So whatever's off this line, it will display that as, or it will not interpret that as a comment. It will think that is a statement to begin executing. Anyway, so there's that. This is actually how C reads things. It doesn't care about the white space, so it just crunched it down with the exception of whenever the white space actually changes the meaning of something. So say int main, you see the color highlighting changes. That's because int main is different than int main like that. Alright, so those are the steps, and you can go to this part right here and you can look at it step by step and you can see what the commands are to execute and then how it works. And then finally, if the user actually inputs any data, that goes to your program, it performs whatever your calculations are, and then it displays the results of that operation back. So I think that's enough for one video. In the next video I'm going to cover some testing and some simple stuff you can do to help out your code.